You're standing still right now. The ground feels solid, unmoving beneath your feet. But are you moving? How would you know if you were? If Earth is hurtling through space at enormous speeds, why don't you feel it? Why doesn't everything fly off? People say Earth is the center because we don't feel it moving, but that's not an explanation. That's just describing what you feel. The truth reveals itself not through what you feel, but through what you see, when you actually look. The reason has nothing to do with feelings. It's about what happens when you point a telescope at Jupiter. Earth feels stationary. The ground beneath you doesn't seem to move. The sky appears to move around us. The sun rises in the east, crosses overhead, sets in the west. Unto's stars wheel above through the night, tracing perfect circles around the pole. The moon traces its path from horizon to horizon. Of course, Earth is the center. Everything moves around us. But wait, that's just describing appearances. That's, just saying what it looks like. So I ask you, what would it look like if Earth were moving? How would you tell the difference? Imagine you're on a ship with no windows, sailing smoothly across the sea. How do you know you're moving? You don't. Everything inside the ship moves with you. Drop a ball, it falls straight down, not backward toward the stern. Pour wine from a pitcher, it falls into the cup normally, as if you were standing still on land. The ship's motion is shared by everything on it. A fly buzzing around inside doesn't get slammed against the back wall. It flies normally, landing on any surface it wants. You could play cards, eat dinner, conduct any experiment you like, and you'd never detect the ship's motion from inside. Here's the key insight. Smooth, constant motion is invisible to anyone moving with it. You cannot detect it from inside the system. You need to look outside, at something not moving with you. The shore, passing ships, the stars, which means, feelings tell us nothing about Earth's motion. We need to look outside our system. The ancients looked, they measured. Ptolemy, working in Alexandria in the 2nd century, placed Earth at the center, with everything orbiting in circles. But there was a problem. Planets don't move in simple circles across the sky. They wander. That's what planet means in Greek, wanderer. They move generally eastward against the stars, but then they stop, go backward sometimes, what we call retrograde motion, then forward again. They speed up, slow down. Ptolemy's solution: epicycles. A planet moves in a small circle, and the center of that small circle moves in a larger circle around Earth. He added more circles, circles on circles on circles. It got complicated. 80 circles or more to explain all the planetary motions. But it worked. You could predict where Mars would be next month, where Venus would appear. The mathematics was sound. But was it true? In 1543, Nicholas Copernicus published the different idea. What if the sun is the center, and Earth is just another planet orbiting it? Suddenly, retrograde motion makes perfect sense. When Earth, moving faster in its inner orbit, overtakes Mars in its outer orbit, Mars appears to move backward against the distant stars. It's like when you pass a slower cart on a road. For a moment, relative to the trees in the distance, the cart appears to move backward. Not really. Just from your moving perspective, all those epicycles Ptolemy needed? Gone, replaced by simple circles. Elegant, beautiful mathematics. But Copernicus had no proof, just simpler mathematics. Fewer circles. That's not evidence. That's preference. Most people rejected it. We'd feel Earth moving, they said. If Earth spins, the wind would blow everything off the surface. Birds flying west would be left behind. We'd fly off into space, and I couldn't answer that, not with words. Not yet. Then I built the telescope. January 1610. I point my telescope at Jupiter. The bright wanderer visible in the evening sky. I see Jupiter clearly, but also 3 small stars near it. Bright points, arranged in a line parallel to the ecliptic. Curious. Next night I look again. They've moved. Different positions relative to Jupiter. All 3 are now on the other side of the planet. The night after that, one has disappeared entirely. Only 2 visible. Where did the third go? Behind Jupiter. The next night, 4 are visible now, in yet another arrangement, 2 on each side. I observed them every clear night for a week, 2 weeks. I sketched their positions carefully. They're not stars. They're moons. They're orbiting Jupiter. I can see their motion night by night. I can predict where they'll be. 4 moons circling Jupiter like a miniature solar system. Think about what this means. Here's a small cosmos, right there in my telescope, of 4 objects circling Jupiter while Jupiter itself moves through the sky. They don't get left behind as Jupiter travels. They don't fly off into space. They move with Jupiter, accompanying it on its journey, just like objects inside the ship move with the ship. The ship analogy was right, but now I can show you a working example in the heavens themselves. This is proof that not everything orbits Earth. At least 4 objects, these moons of Jupiter, orbit something else. The ancient assumption, all celestial motion, centers on Earth. Wrong. If Jupiter can have moons that travel with it through space, why can't Earth? Why shouldn't Earth be a planet with a moon orbiting the sun? But that's not what collapsed the old picture completely. Venus did. Venus is visible just after sunset or just before sunrise. The evening star, the morning star, never far from the sun in the sky, never visible at midnight. I point my telescope at it. Venus has phases, like the moon. Full Venus, half Venus, crescent Venus, not just bright and less bright, actual phases, with a clear edge between light and shadow. I track it over months. Full, then gibbous, then half, then crescent, then back to full again. A complete cycle. Here's the problem. If Venus orbits Earth, you would never see full Venus. Think about the geometry. Draw it out. If Venus circles Earth, it would always be either between us and the sun or behind the sun from our perspective. When between us and the sun, we'd see its dark side, crescent or nu. When behind the sun, we couldn't see it at all, hidden in the sun's glare. You'd see only crescents at best. Never full, never gibbous. But we see full Venus when it's on the far side of the sun from us. We see crescent Venus when it's between us and the sun. We see all the faces in between, the only way that works. Venus orbits the sun, not Earth. Geometry forces this conclusion, not philosophy, not preference, not religious doctrine, measurement and geometry. The observations cannot be explained any other way. And so you see, the evidence accumulates. But people still asked, yes, fine, Venus orbits the sun, but where's the proof Earth moves? If Earth moves around the sun, nearby stars should shift position relative to distant stars. It's called stellar parallax. Like when you move your head side to side, hold your finger at arm's length and move your head. Your finger shifts against the far wall. The principle is the same. If Earth moves from one side of its orbit to the other, a distance of nearly 200 million miles, nearby stars should shift against the background of more distant stars. Oh, I looked. Others looked. No parallax visible. The stars appeared fixed in the same positions year-round. Critics seized on this. See? Earth doesn't move. If it did, we'd see parallax. They thought this disproved Copernicus. But wait, maybe the stars are just very far away. If they're distant enough, the parallax would be too small to see with our instruments. Our telescopes, as good as they were, still had limits. This actually made sense of something else that puzzled people. Stars look like points, not disks. Even through my telescope, they remain dimensionless points of light. The planets show disks. I can see Jupiter's shape, Venus's phases, but stars, just points. If they're suns like ours but incredibly, unimaginably distant. That explains why. They're so far away that even their enormous size shrinks to a point from our perspective. I couldn't prove Earth moved. Not directly. Not with parallax. We'd have to wait for better instruments, and in fact, stellar parallax wasn't measured until 1838, 2 centuries later. But I could show the old picture was wrong. I could show that planets are worlds, that not everything orbits Earth, that the heavens aren't fundamentally different from Earth. The question was shifting. I discovered spots on the sun, dark blemishes on its surface. The sun wasn't supposed to have imperfections. It was supposed to be a perfect heavenly body, made of pure celestial substance, according to Aristotle's philosophy. But there they were, dark spots. I tracked them carefully, day by day, when the sun was low enough and filtered enough to observe safely. The spots move across the sun's face in about 2 weeks, disappear at the western edge, then reappear on the eastern edge 2 weeks later. The sun rotates. It takes about 27 days to complete one rotation. We can measure it precisely from the sunspot motion. If the sun rotates, why shouldn't Earth? What makes Earth special? But more than that, the spots prove the sun isn't perfect, isn't unchanging. It has features. It changes. The heavens are made of the same kind of substance as Earth, not a fundamentally different, incorruptible substance. No reason they should follow different laws. The old Aristotelian division between the celestial realm and the terrestrial realm, it breaks down under observation. The cosmos is unified, not divided into fundamentally different zones. But here's what really couldn't be explained away. Let me show you exactly why geometry forces the conclusion about Venus. Draw this out if you have paper. If Venus orbits Earth inside Earth's orbit, always between us and the sun, we would see only crescent phases, never full or gibbous. It would be like perpetually looking at the dark side of the moon. The lit side would always face away from us, toward the sun. If Venus orbits Earth outside our orbit, always on the far side from the sun's perspective, we'd see mostly full phases. Never crescent. The lit side would always face us. But we see all phases. Full Venus when it's far from us, on the far side of the sun. Crescent Venus when it's near us, between us and the sun. Half Venus in the positions between, the full cycle. Only one configuration explains this. Venus orbits the sun, and we're observing it from different angles as both Venus and Earth move in their respective orbits around the sun. And there's more. When Venus is full, it appears small in the telescope, barely, larger than a star. When Venus is a crescent, it appears large, more than 6 times the diameter. The size changes match the predictions exactly if Venus orbits the sun. Full Venus is far away, on the opposite side of the sun from us, perhaps 160 million miles distant. Crescent Venus is close, only about 26 million miles away, between us and the sun. I measured the angular diameter across different phases, carefully. The numbers matched the Copernican model exactly. Not approximately, exactly. This isn't interpretation open to debate. This is geometry. You can draw the triangles yourself, work out the distances, the angles, the apparent sizes, and you'll see there's only one arrangement that produces what we observe. And that's when everything had to change, not because of philosophy or preference, because of measurement. So you're moving, right now. Earth is spinning on its axis, about 1,000 miles per hour at the equator, slower at higher latitudes. Earth is orbiting the sun at 67,000 miles per hour. The sun is moving through the galaxy at roughly 500,000 miles per hour. Why don't you feel any of this motion? Same reason you don't feel motion on the ship. Smooth, constant motion is invisible to anything moving with it. You only feel changes in motion, acceleration, deceleration, turning. Earth's spin and orbit are smooth enough, constant enough that you don't notice. Everything moves together, the air around you, the birds, the clouds, you. The wine falling into the cup still falls straight down relative to you, even though you're hurtling through space. But mountains would fly off from the spinning. No, wrong. Gravity holds everything down. The gravitational force pulling you toward Earth's center is far stronger than any outward effect from rotation. We can calculate this. The centrifugal effect at the equator, the tendency to fly outward from spinning, is about 0.3% of the gravitational force. Negligible. Gravity wins by a factor of 300. We measured, we calculated. The numbers work. The old intuition that stationary feels stationary, therefore is stationary, is wrong. Motion is relative. It depends on your frame of reference. You feel stationary relative to Earth, but Earth isn't stationary relative to the sun. The sun isn't stationary relative to the galaxy. There's no absolute rest, no absolute motion, only relative motion, which raises something deeper about the cosmos itself. Is there even a center to the universe? The sun is the center of our solar system, yes. But the sun moves too. It orbits the center of the Milky Way galaxy, taking about 230 million years to complete one orbit. The galaxy itself moves through space relative to other galaxies. Where's the absolute center of everything? Where's the fixed point? Maybe there isn't one. Maybe center is just whatever you choose as your reference point for calculation. The universe has no preferred position, no special location from which all else is measured. Earth isn't special in that sense. The sun isn't special. We're on a planet, orbiting a star, in a galaxy among billions of galaxies scattered through space. Not the center, not unique in position, just one place among many. This is what the telescope revealed. We're not privileged observers occupying a special location around which the cosmos revolves. We're participants in it. The universe doesn't exist for our benefit or revolve around us. It simply exists, and we observe it from our particular location, which is not special. And I know what you're thinking. What happened when I said this? In 1616, the Church declared heliocentrism false and absurd, philosophically and formally heretical. They told me not to teach it as fact, not to defend it. I could describe it as mathematical hypothesis, nothing more. In 1632, I published anyway, Dialogue Concerning the Two Chief World Systems. I put the arguments in the mouths of three characters debating. One defends Aristotle and Ptolemy. One defends Copernicus. One moderates. I thought putting it as dialogue, as characters discussing, would protect me. It didn't. Everyone knew which character represented my view. In 1633, the Inquisition summoned me to Rome. Trial. I was 70 years old. They wanted me to recant, to say I was wrong, to abandon heliocentrism. I did recant, formally. I read their statement. But the observations don't change because someone orders them to. Jupiter's moons still orbit Jupiter whether the Church approves or not. Venus still shows all its phases. The geometry remains true, regardless of doctrine. They put me under house arrest for the rest of my life. I died in 1642, still confined. But here's what they couldn't suppress. You're still standing there, feeling stationary. But now you know, that feeling is just your frame of reference. You're spinning on a rotating planet, orbiting a star, in a galaxy moving through space. You're hurtling through the cosmos at speeds that would seem impossible if you stopped to think about them, and every measurement we've made since confirms it. The parallax we couldn't see in my time, finally measured in 1838 by Friedrich Bessel. He measured the parallax of the star 61 Cygni, a shift of less than 1/3 of an arc-second. That's the angle subtended by a coin viewed from 4 miles away, incredibly tiny. But it's there. The stars are unimaginably distant. 61 Cygni is about 11 light-years away, which is why the parallax is so small. But Earth's motion creates it. The stars shift because Earth moves. Earth moves. This is not interpretation. This is not philosophy. This is geometry. You can verify yourself. And if Earth moves around the sun, what makes it move? What holds the planets in their paths? Why don't they fly off into space or fall into the sun? That's Newton's question now. Different geometry, different proof. I've told you what I saw through the telescope, the evidence that forced us to abandon Earth's special position. I'll leave you to imagine what invisible force holds it all together.